Now, so it says that there is a ball. There is a ball whose there is a solid rubber ball. The ball is taken from the surface to the bottom of the lake. The depth of the lake is 360 meters, and the the volume gets reduced by 0.0012%. And the density of the water is given to us. Okay, depth D is given to us, that is 360 meters, and density of water is 1000, 10 to the power 40 kg per meter cube, and gravity value is also given to us 10 meter per second square. And calculate the bulk modulus B equal to how much? What is the formula for bulk modulus? Bulk modulus formula is B equal to pressure by change in the volume by original volume, right? Change in volume by original volume. So what do we write here? B equal to how much? P into V divided by delta. First we'll calculate pressure. Pressure is equal to rho GH. So pressure is 10 to the power of 3 into 10 into 360. So pressure P is equal to how much? 3.6 into 10 to the power of 3, 4, 5, 6. Okay, pascals. Okay, 3.6 into 10 to the power of 6 pascals. Okay, and now what is change in volume by original volume? So what he said, change in volume by original volume is 0.0012%. Okay, percent means 0.0012 by 100. That is the value of change in volume by original volume. So 1.2 into 10 to the power of 1.2 into 10 to the power of minus 5. It's a ratio, so no need to calculate the value. Now, so don't write the unit for that. Okay, so bulk modulus, now substitute the values. So B equal to how much? 3.6 into 10 to the power of 6 into 1.2 into 10 to the power of 5. So bulk modulus equal to how much? Multiply these two. 3.6 into 1.2, that will become 3.2 divided by, sorry, change in the volume by original volume. So it will become divided by. So 1.123 is 36. 3 into 10 to the power of 5 and 10 to the power of 1. So 10 to the power of 11. 11 Newton per meter square. This is the formula. This is the value. Is it clear, girls? See, there is a numerical here. Just I will finish off this, then we'll go to the oscillations chapter. Now, what it says is, when a solid rubber ball is taken from the surface of the solid rubber ball, it is taken from the surface of the lake to the bottom of the lake. The depth is 360 meters. The volume gets reduced by 0.012%, and then density is given to us and gravity is given to us. So just write those given values and substitute in the formula. B is equal to P by delta V by V. So substitute in the formula. P is equal to rho GH. We got P value. Change in volume by original volume is also given to us. B is equal to divide this value by that value, we get the answer. Is that clear? Is it clear, all of you?
Yes, sir.
Okay.
Yes, sir.
Okay, just see, just check whether you are in 11A1 and 11A2 team. If you aren't there, just type your name in the, type your admission number in the chat box, okay?
Sir, I have a doubt.
Yes, please.
So the pressure at a point 360 meter below should be PA plus rho GH, right? Why are we only considering
Rho GH, no? P plus rho GH, yeah, I understood. That's gauge pressure, yeah. I do understand. Only if you are not, as of now, we are not calculating because there is a pressure acting here also, right? PA is acting here also, PA is acting at this point also. So don't take that into consideration now. Got it?
Sure.
We're only calculating the bulk modulus. How much is the bulk modulus at the bottom of the lake? On the ball at the bottom of the lake. Please check whether you are there in the teams 11A1 and 11A2 name, the team. Okay, whether if you are not there, please write your admission number in the chat box so that immediately after this meeting, I can start that meeting. Okay. This is the name of the meeting, 11A1 and 11A2. Name of the team. Yes, are you done with this? I will start with oscillations now. Okay. Now, can I erase this now? Yes, girls. Can I erase it now? Yes,
sir.
Yes, sir.
Yes, sir.
Okay, we will start with oscillations chapter. Quick recap and because 11A2 I haven't done, I'll be doing I'll start from the beginning. This lesson and the next lesson is very, very important for your grade 12. These two are the conceptual lessons. Why? Because there are three lessons, that is alternating currents chapter and electromagnetic waves and wave optics. These are the three lessons. To understand these three lessons, you need, this is the basic, oscillations and waves. Okay. So now in oscillations, so we have total how many types of motions? Total, there are 4 types of motion. One is linear motion. Yeah, linear motion, circular motion, then rotatory motion, and last one is oscillatory motion. All are sleeping now. Huh? Nice, because weather is very cold and it is windy. So now linear motion. What is a linear motion? When the body is moving in a
Straight line.
straight line. Very good. When the body is moving in a straight line, then that is known as a linear motion. What is circular motion? Circular motion means when the body is moving about a
Circular. So about a point.
About a fixed point.
If the body is moving about the fixed point, then that is known as circular motion. What is rotatory motion?
Motion about a fixed axis.
Very
Bottom
good.
axis.
Motion of the body about the fixed axis is known as rotatory motion. What is oscillatory motion?
One from
One from
To and
motion.
fro motion. Very good. To and fro motion is of the body is known as oscillatory motion. Now there is a difference between oscillatory and we have vibratory. If the oscillations are small, then that is known as
vibratory.
Yeah, it is known as, if the oscillations are small or less than 10, then it is known as oscillatory. If it is more than 10, very high oscillations are known as yes, very high oscillations are known as vibratory motion. Is that clear? Now, next we have periodic motion. What is periodic motion? What is periodic motion? What is periodic motion? Hannah, did you check whether we both you are added in the team? Did you check that? Please check that. Okay,
Yes, sir.
those whose names are not there in the team, please write your admission number. I will add you in the team now itself, so that immediately once the meeting ends, I can start that meeting. Now, periodic motion. What is periodic motion?
It repeats again and again.
A
But
motion,
develop-
the motion in which the body repeats itself after regular intervals of time. Okay, the motion in which the body repeats itself after regular intervals of time. Then that is known as periodic motion. Okay, then that is known as periodic motion. 1 second. Yeah, one more number has come. 1 second. Just 1 second. So periodic motion is what? A body in which the motion in which the body repeats itself after regular intervals of time. Then that is known as periodic motion. Can you give me the example of periodic motion?
Motion of swing.
Yeah, motion of the earth around the sun, motion of the moon around the earth. These are all the periodic motion. So can we say motion that oscillatory motion is a periodic motion? Oscillatory motion is a periodic motion. Can we say? Girls, other class.
Yes.
No one is
Yes.
responding. Please do respond. Okay. Don't be quiet. It will become very difficult for me. 1 second. Give me 1 second. Yeah. Now, so what is there now? This is periodic motion. So we can write 2 and so now you can write simple pendulum. This experiment you have already done in your lab, right? In the lab, you have already done this experiment. So this is the extreme position and this is the mean position. So what is oscillation? Go to the end from the center to this one. This is one complete oscillation. So the body comes to its point again and again towards its mean position. Okay, now we will go with the frequency. What is frequency? What is frequency? Denoted by nu. Okay, what is frequency? No one is responding. Number of oscillations in number of oscillations made in 1 second. Okay, number of oscillations made in 1 second is known as frequency. Unit of frequency is what? Measured in hertz. Okay, named after the scientist, hertz. CPS means cycles per second. This is SI unit and this is CGS unit. Okay, it is hertz. Okay, second one is time period. What is time period?
Time taken to complete.
Time taken to complete one oscillation.
Very good. Time taken to complete. Time taken. It is there in chemistry also. Time taken to complete one oscillation. In the first lesson of chemistry, one oscillation is known as time period. Now, units of time period is it can be measured in seconds, milliseconds, microseconds, nanoseconds. These are the examples. Next is what? Amplitude. What is amplitude? Amplitude is capital A. Okay. Maximum displacement of the particle. Maximum displacement of the particle. Maximum displacement of the particle from its mean position. Maximum displacement of the particle from its mean position is said to be what? Amplitude. Unit of amplitude is what? Meter or centimeter. Okay. Is it clear, girls?
Yes, sir.
Yeah. So once again, frequency is number of oscillations made in 1 second. Unit of frequency is hertz or CPS. CPS means cycles per second. Measured in hertz. Okay. Next is time period. Time taken to complete one oscillation is said to be time period, and it is measured in seconds or milliseconds or microseconds or nanoseconds. What is amplitude? Amplitude is maximum displacement of the particle from its mean position. That is said to be amplitude. It is measured in meters or centimeters. Clear? Next, wavelength, and then we will start phase. Very, very important concept. Okay, so can I erase this now? The left hand side. Can I erase it? Yes, no?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. Now, you can take the screenshot and write later on also, no problem. Now here, next one is what? Wavelength. What is wavelength? Wavelength is denoted
Distance
by,
between two crusts away.
yeah, distance between any two successive crest or distance between any two successive crest or trough is wavelength. Okay, or this is or length of one wave is also known as wavelength, lambda. Okay, or if you're taking this way, you can write like this also. Distance between two successive crest or trough is known as wavelength, denoted by lambda. Now, units of wavelength is again measured in meters or centimeters. Next is phase. What is a phase? What is phase? Are you understanding 11A2 girls? Are you people understanding these concepts?
Yes, sir.
Yes, sir.
Yes.
Okay, what is phase? It describes, there are two definitions. Okay, it describes, you have to understand this concept. Okay, it describes the state of motion and direction of a particle. It describes the state of motion and direction of the particle. Okay, it describes the state of motion and direction of the particle. Okay. Now, so or it is also written as angle made with its initial position. Angle made with its initial position. Angle made with its initial position is said to be what? Phase. Clear? Angle made with its initial position. Oh, sorry, it went down. So angle made with its initial position is known as phase. Is that clear? So describe the state of motion and direction of the particle. Now, now here, see, suppose. Now here, the particle was supposed to start, I was supposed to start my class exactly at example at 8 a.m. I started the time duration for the class is 1 hour. Means my class is from 8 o'clock to 9 o'clock. And I have to take exactly 60 minutes class. Now I started my class 8:05. Then when should I end my class?
9:05.
9:05. Yeah, 9:05. When I started my class 8:05, I have to end my class at 9:05. Suppose I came early and I started my class 7:55 instead of 8. So I should end my class at
8:50.
8:55.
8:55. Is it not? So that is phase. So suppose I should, if I start from here, after completing one rotation, I have to return back. When I come back to this point, I complete one rotation. Now what happened? Instead of starting at A, I started at P. So what happened? The particle will again come back to the same point. Understood? To complete one rotation. Is that clear?
Yes, sir.
So this angle is said to be phi. Is that clear? Now I want to, next concept is not phasor diagram. Phasor diagram. What is a phasor diagram? Phasor diagram is representation of a wave on a circle. Representation of a wave on a circle. Representation of a wave on a representation of a wave on a circle is said to be what? Phasor diagram. So now how do we represent? See here. See, this is a wave. Now when the particle is at A, it will be here on the circle, A on the circle. Now when the particle is at B, it is at P at circle. on the way. When it is at B, it is here. The particle is here. When it is at C, the particle is here. When it is at D, the particle is here. When it is at E, the particle is here. Understood now? Is that clear? Understood? See once again, when the particle is at A, it is here. When the particle is at B, it is here. When the particle is at B, it is here. When the particle is at C, it is here. When the particle is at D, it is here. When the particle is at E, it is here. Understood now? Is that clear, all of you?
Yes,
Yes,
sir.
Yeah. So that is what how we are representing a wave on a circle. If we are representing a wave on a circle, that is known as phasor diagram. Now, so it describes the state of motion and direction of the particle. Suppose my wave starts from here. Example, on this, my wave starts like this. When should I stop calculating? When does it complete one wave? Whether it completes at A or B or C or D. Tell me now. Suppose my wave started at P. Where should I complete now?
point C.
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 C. Okay, all of you agree with C?
Yeah.
Yes,
Yeah,
sir.
it is correct. C is correct because it completes one wave here. Is that clear? Suppose there is one more situation where the wave already it started maybe after a certain angle like this. Instead of starting like this, it started like this. Okay. It started.
We can't see, sir.
No, you can't see. Okay. I'll draw on the same. Instead of like this, the particle started like this. The dotted line. Are you able to see the dotted line? Now, again. So this is, now we will write again. P, Q, R, S. When will it complete one wave? P dash.
P.
At P, right? Because see, there was a phase, right? It was supposed to start from here, but what happened is, here in this case, it started little late. So that's why we are ending at this point. Now it started early, so we stopped it early. Is that clear now? This angle,
Yes, sir.
this angle is said to be phase angle. Got it now? Understood, all of you? Is that clear? In this case, this is the
Yes,
phase
sir.
angle. In the first case, this is the phase angle. In the second case, this is the phase angle. Got it now? Understood, all of you? Yes or no?
Yes, sir. Yes, sir.
Okay, going ahead with the next one, next concept. Okay, so next concept is in phase, out of phase, and constant phase difference. Okay, so once we are done with that, then we can go with a representation of a equation of a wave. So those who missed the classes due to any unavoidable circumstances, you can, anyway, the revision is being done. Okay, now, so please once again I say, suppose if your name, if you are not added in the team, in that, okay, only 10 minutes are left now. If anyone is not added in the team in 11A1 and 11A2 team, please do write your admission number here. I will add immediately. Okay. One second. Please cross check also. I'm adding it simultaneously. Now, now we will go with in phase. In phase. In phase means angle is how much? 0 degrees. Means example, there are two waves. Like this. It can be of same amplitude or different amplitude also. See? The second wave is also same. Two waves are there. One is y1. The second one is y2. y1 and y2. Angle is how much here? Phase angle is 0 degrees. Okay. Example, you are watching a movie and you understand the movie at the same time. Okay. Then that is known as in phase. You are in phase. You're talking to your friend. Okay, and whatever she says, you understand at the same time. Then you are in phase, is it not? You are in phase. Clear? So
Yes.
in phase means both the waves, there is no phase angle between the waves. It is 0 degrees. Out of phase. Out of phase is phi is equal to how much? 180 degrees. Out of phase is phi is equal to 180 degrees. Now what happens in this case? Now this is the wave, and the other one is starts like this. Okay, one is y1, the other is y2. So in this case, what happened? Like suppose, example, one of the student wanted to go to a picnic with the friends, and immediately she started running towards the mother or father, and she said that I wanted to go with my friend, all are ready and all everything, all the preparations are made. Immediately the parent says, just go and study. Okay, to study for the annual examination. We are not going to go anywhere. What happens? Your mood gets spoiled, right? Completely out of order now. Okay, you get annoyed. So out of phase. This is out of phase. Means the angle is how much? When you completely there's a way of understanding, analogy. I'm just saying. It's not like. So in the wave, what happens exactly? So this is, if one is the angle between both the waves is how much? 180 degrees. That's the difference. Next is what? Constant phase difference. Constant phase difference. Constant phase difference. Maybe angle is some theta, something like that. Like suppose, or we say leading or lagging of a wave. See here. So here we have one is y1, one is y2. Okay, we say leading or lagging of a wave. Leading or lagging of a wave is known as what? Leading or lagging of a wave is known as constant phase difference. Is that clear? Is it clear with you all? Yes or no?
Yes, sir.
Yeah. One is leading and one is lagging. Suppose the teacher is teaching the class, and after some time, okay, I won't take the name, don't worry. So some of you say, I understood now. Oh, it was that much only. I like that. Is it not? Is it clear? So that is leading or lagging of a wave. It happens like even when you are talking on the phone, sometimes the signal lags. Is it not? That is, you are saying hello, after 1 second, they hear hello. Is it not? That is said to be the constant phase difference. Is that clear? That's said to be constant phase difference. So leading or lagging of a wave is known as constant phase difference. Understood? Now, okay, so we have in phase, we have out of phase, and we have constant phase difference. Now we will represent. Now we will write SHM, simple harmonic motion, and we will write equation of a wave also. Okay, SHM. What is simple harmonic motion? The motion in which force and displacement, they are proportional to each other in the opposite direction. Force and displacement both are acting in opposite direction. Like suppose, example, I'm taking one example of spring mass system to make you better understand this thing. Okay, this is a spring mass system. This is the mean position. Now, now suppose this is, this is mean position. Okay, see here, we can see three situations here. There are three situations here. Okay, three situations. Now this is mean position. These two are the extreme positions. Force is in this way, displacement is in opposite direction. Here force is in this way, displacement is in opposite direction. Are you seeing this? See, when this is in the compression position, this is the extension position. This is mean position, normal position. So when you compress, the spring will try to come out, will try to come back to its same position, right? Even when you extend also, it will try to come back to its same position. So force and extension both are in opposite direction. The motion in which force and compression or extension both are in opposite direction, then that is known as simple harmonic motion. So simple harmonic motion is a special case of periodic motion. Is that clear? SHM, simple harmonic motion, is a special case of simple harmonic motion or periodic motion. Is that clear, all of you? Is it clear? all of
Yes, sir.
Very good. Now, so you may ask me now, the next question, sir, F is equal to Kx, or F is equal to minus Kx. What is K here? K is spring constant. K is spring constant. Again, what is spring constant? That we will write. Did you note down this one? Can I erase this now? Can I erase this now?
Yes, sir.
Yeah. Yeah. 1 second. Now, are you clear with all of you clear with in phase, out of phase, and constant phase difference? Very, very important. Grade 12, if you go to grade 12, interference chapter is there in wave optics. Definitely you will come across in phase, out of phase, and constant phase difference. To understand how the CD player works, again this phenomena. To understand how you are able to talk on the phone, the same phenomena. To understand optics or to understand electromagnetic waves, how they travel in space, you have to understand this first. If you don't understand this, you can't go ahead. Okay. All this is the actual foundation thing for the waves. Is it clear, all of you? Is it clear? Yes? No one is responding. Yes or no? If anyone is left out in the, if anyone is not added in the team, please do write your admission number in the chat box. I'll immediately add it to the teams. Immediately after the Zoom meeting ends, there is only 1 minute, 30 seconds. If once this is end, once the meeting ends, immediately I will start the team meeting. So you can join the team meeting. Okay. Is it clear, all of you?
Yes,
No.
sir.
Yeah. Now, next one. Next one here is we have, so F is equal to Kx. What is spring constant? Let us discuss this. Spring constant is denoted by K. Okay, spring constant means stiffness or hardness of the spring. Stiffness or hardness of the spring. Stiffness or hardness of the spring is said to be spring constant. So what is that? Units of spring constant is what? Newton per meter. Okay. So how do we calculate this? We write like this. F is equal to mg. How do we calculate this? So there is a retard stand here. There is a retard stand here. On the retard stand, we fix a spring. Okay. The length of the spring is, let it be L. Now I I add some weight to it. So what happens here? The length of the spring will extend. The length of the spring will extend. That is L dash. So what is that? L dash minus L. Okay, let it be delta. Okay, or X, let it be X. Now what happens here? So here we